In Chapter 15, Solutions, today we're going to talk about the stoichiometry of solution reactions. There are steps for solving these types of problems. We're going to make sure that we write the balanced equation. For the reactions involving ions, it's best to write the net ionic equation. We calculate the moles of reactants, determine which reactant's limiting, calculate moles of other reactants or products as required, and then convert to grams or other units if required. Let's take a look at how to do an example problem. We have 10 milliliters of a 3 molar solution of sodium phosphate, and it reacts with 20 milliliters of a 0.2 molar lead 2 nitrate solution. What precipitate will form? So let's start off by looking at what we're dealing with. We have sodium phosphate, which is going to be Na3PO4. And we're going to put that with 20 milliliters of a 0.2 molar lead 2 nitrate solution. So there's PbNO3, 2, and we can put the information underneath here, but for right now we'll just go with this because we're looking at the precipitate. What precipitate will form? So this is a double date switch, so we're going to put sodium with nitrate. And if you looked at your solubility rules, you notice that's aqueous because not only is it a sodium salt, but it's a nitrate salt. Sodium has a +1 charge, nitrate has a -1 charge, so the overall charge here is 0. The other possibility is going to be our lead with our phosphate. So lead in this case has a +2 charge, phosphate has a -3 charge, so it's going to be Pb3PO4, 2 solid that should form for this reaction. So there's our precipitate. And if you look on your sheet of solubility rules, you'll notice that it's a phosphate salt, which are not very soluble at all, and it's lead on top of that, so it's not going to be soluble. It will be a solid. So our precipitate is Pb3PO4, 2. Okay, so the next question is, what mass of precipitate will form? So we're going to find out what mass of Pb3PO4, 2 will form. So let's go back to our reaction and do a balanced chemical equation. Through the wonders of modern technology, I've been able to pause the video and write out the complete molecular equation for this reaction and balance it, and put the information down below each one that it indicates. So I have a 0.3 molar solution of sodium phosphate, and I have 0.01 liters. I changed milliliters to liters. 0.2 molar solution of lead 2 nitrate with 0.02 liters of that solution. I want to find out how many moles. If I'm going to get to mass of Pb3PO4, down here, I'm going to have to determine how many, which one of these two, first of all, is our limiting reactant. And in order to do that, I have to first find out mole to mole ratios. So I have to find the number of moles. So right now I have 0.3 moles of Na3PO4, and that was just done the same way as I'm going to do this one. I take 0.2 molar solution equals X moles over 0.02 liters. So I cross multiply 0.2 times 0.02, and my number of moles is 0.004 moles. I do my mole to mole ratio. I say if I use up all my Na3PO4, which is 0.003 moles, and my coefficient for that is 2. My coefficient for the lead 2 nitrate is 3. How much lead 2 nitrate would I need to react? So I'm going to take 0.003 times 3, and I'm going to divide that answer by 2, and my answer is 0.0045 moles of PbNO3, 2 that I would need. This is how much I have. The question is, do I have enough? The answer to that would be no. Since I don't have enough, this is what limits me. So there's my limiting reactant. Now I take my limiting reactant over here to my product. So 3 is 2, and what I have is 0.004, as 1 is to x. So 0.004 times 1 divided by 3, x equals 0.0013 moles of Pb3. PO42. Now we need the molar mass of Pb3PO42. The Pb3PO42 is a pretty hefty molecule. I calculated the mass to be 811.54 grams per mole, so 0.0013 moles times 811.54 grams over 1 mole. Cancel my moles. And I have that I'm going to need 1.06 grams produced from this reaction. So if we want to look at it in words instead of numbers and check out the direction we need to go when answering a question like this, we have to know where we're going. We want to know the mass of the solid Pb3PO42 that's formed. And we got there by doing a process that we're very familiar with, only this time instead of gas laws to deal with in stoichiometry or just regular limiting reactants with multimole ratios, without any other kind of gas laws or anything else put in, we add in addition to that molarity. So it's just a few more steps that you have to take in order to get to the answer, and we'll continue to practice these in class.